Hello, everyone. Welcome to this live session on learning mathematics through concepts and examples. Today, we are going to explore algebraic operations on functions. So let's begin with our first example. So here is the brief outline of what we are going to achieve by the end of this session. So by the end of this session, you'll be able to perform various algebraic operation involving function. So we'll talk about things like addition, subtraction, multiplication, and division of the functions, including the operations like composition as the various operations and functions. So we are going to look at some of those here. You're definitely going to learn how to compute or how to find the composition of functions. And finally, you are also going to learn how to evaluate the composition of functions. Okay, first example. If f of x equal to 1 over x minus 1 and g of x equal to x squared, find the following. So we are asked to find these three. So let's begin with the first one. So in part A, okay, in the first part, that's part A, we are asked to find, in part A, we are asked to find f minus g of 2. So clearly you can see that this is the difference of two functions. So this can be written as f of 2 minus g of 2. Okay, that is f of 2 minus g of 2. Now, if you look at the function carefully, f of 2 will be, if I want to find f of 2, I have to plug in 2 into this function f of x. So it will be 1 over 2 minus 1. There is x minus 1. So that will be 1 over 2 minus 1. Then minus g of x is x squared. So g of 2 will be 2 squared. 2 squared. So that is equal to, okay, 1 over 2 minus 1. 2 minus 1 is 1. So 1 over 1 is 1. 1 minus 2 squared is 4. So 1 minus 4 is a negative 3. So the first part, which is f minus g of 2, is a negative 3. So basically what we are doing here is we are plugging in the value and then computing the value of the function. So that is what we did in part A. Now let's move on to part B and find out what we are asked to do there. Okay, in part B, you can see we are asked to find g over f of x. G over f of x. So this is same as g of x divided by f of x. That is the meaning. Okay, g of x divided by f of x. So now we can write the value of individual functions and then simplify this one. So g of x, as you can see here, the value of g of x is x squared. So x squared, then divided by f of x. F of x is 1 over x minus 1. 1 over x minus 1. Or that is the reciprocal of x minus 1. Now, we know that if we are dividing the fraction like this, we do this x squared. We change the division to multiplication and we take the reciprocal of this second. Reciprocal of 1 over x minus 1 is simply x minus 1. So now this can be simplified to, you can distribute this. X squared multiplied to x is x cubed. And then when we distribute here, you can see x squared multiplied to 1 is x squared, but there's a negative in front, so that'll be minus. So the value of g over f of x is x cubed minus x squared. So that is our part B, this one here. And in part C, we are asked to find this composition, GOF of 3. So let's see what is GOF of 3. So in C, we are asked to find GOF of 3, the composition of function g with f evaluated at 3. So that is equal to, we can write like this, we can write g of f of 3, because f of 3 is your inside function. So now we can keep this g as it is. We write that g, and then f of 3, you can see f of x is 1 over x minus 1. So f of 3 will be, we plug in 3 here, so it will be 1 over 3 minus 1. So this can be written as 1 over 3 minus 1, which is equal to g of 1 over 2. 3 minus 1 is a 2. So it becomes g of half. And we know that g of x is x squared. So g of half will be half squared. Okay, g of half is half squared. Now we have to square numerator and denominator separately here. So if we square 1, that's a 1. And then over, if we square this 2 is squared, that will be 4. That will be 4. So our result for this one is 1/4. So you can clearly see in the first one, we are asked to evaluate the difference. So we compute f of 2 minus f of 2 minus g of 2, and we got a -3 for the first one. In the second one, it was the division of a function, a function divided by the other function. And we use the simple concept of the division of fraction to get the result x cubed minus x squared in part B. And in part C, it is just plugging in the value in that composition, and we obtain 1/4 as the answer. So this is one way, okay, to deal with the composition and operation of function. Part C is the operation of function. Part A and B are the composition. In part A and B, we have the difference. Addition follows the same thing. Sum will follow the same procedure. And in this one, in B, we did the division. Multiplication is similar. You just multiplied two functions there. Okay, time for next example. So in this one, we are asked to find the composition f of g of x and g of f of x when these two functions f of x and g of x are given to you. Okay, two functions f of x and g of x are already given to you. So that is our f of x, that's our g of x, and we need to find the composition. So let's see, the first one is we have to find f of g of x, which is same as f of, okay, f of g of x, which is same as f of g of x. We write the value of g of x. Inside function is g of x. So we write the value of g of x as x plus 2. Okay, we have to write the value of the inside function. Inside function is g of x. So we write the value of g of x, which is x plus 2. Now we have to evaluate the function f at x plus 2. That is the meaning. Function f is the square root of x plus 1. So this will be equal to square root of, in place of x, or in here the point in the domain is x plus 2. So in place of x, we write x plus 2, then plus 1. So the result will be square root of x plus 3. Okay, result will be square root of x plus 3. So that is the composition of f of g of x. Now let's find the other one, g of f of x. G of f of x. So it is the other way around. Okay, so if we perform this composition, let's see what we have. Our outside function is g, so we keep that as it is. And then inside function is f of x. And f of x from here, up here, we know that it's a square root of x plus 1. Square root of x plus 1. So that will be equal to, so g of square root of x plus 1. You know that g of x is x plus 2. So it will be this quantity plus 2. So it will be square root of x plus 1 plus 2. So that is the composition here. Note one thing, you can see that f of g of x and g of f of x, they are not equal. So for a quick note here, note, in general, f of g of x is not equal to g of f of x. Okay, in general, they are not equal. They will be equal. There is one special case when they will be equal. They will be equal if f and g are inverse of each other. So if f and g are inverse of each other, okay, inverse of each other, then we can say f or g of x is equal to g o f of x. Otherwise, these two quantity will not be equal. They are equal only when only when f and g are inverse of each other. And also remember this condition, okay, this statement here, if f and g are inverse of each other, then f o g of x is equal to g o f of x. We use these to verify whether two given functions are inverse of each other or not. If two functions are given and you are asked to test whether they are inverse of each other or not, you just find these two and they will be equal to, in this case, let me write this down here so that it looks clear for all of you. Okay, then f o g of x will be equal to g o f of x. And also remember, this is equal to x. Both of them will be equal to x. It will be identity function. In that case, the function f and g are inverse of each other. So for this problem, you don't need to write this note portion. The only thing required is these two steps up there. Okay, that's our second example. Let's move on to third example and find out what we have now. Okay, here is the next one. Here also two functions are given. As you can see, there are two functions, which is f of x, which is given here, and g of x that is given here. And we are asked to determine the composition f o g of x, and also we are asked to evaluate that composition at 1. So the first one, in part A, we have to find f o g of x. So that is same as f of g of x. G of x is the inside function, and g of x is 3x minus 1. 3x minus 1. Now, what we know is the function f, what it does is it squares the value in the domain, okay? It squares any value in the domain and then reduce that by 4. So f of 3x minus 1, it follows the same procedure. So it will square this value and reduce by 4. So it will be 3x minus 1 squared minus 4. Now what we can do here is, if you look at this, this is 3x minus 1 times 3x minus 1, then minus 4. Because 3x minus 1 quantity squared is 3x minus 1 times 3x minus 1. So over here, we can actually FOIL this one. So if we FOIL this or multiply, you will get 9x squared minus 6x plus 1. And at the end, there is minus 4. And when you simplify, you get 9x squared minus 6x minus 3. So that is the composition. Okay, that is the composition of the function. This one here, f o g of x. So f o g of x is 9x squared minus 6x minus 3. That is our first part. Now let's look at the second part, part B. Okay, in part B, what we are asked to do is we are asked to find f o g of 1. F o g of 1. If you try to understand the meaning of this one, this is f of g of 1. G of 1 is your inside function. Okay, f of g of 1. So now we can write that outside function f as it is. And if you think of g of 1, you can see g of x up here. G of x is 3x minus 1. So g of 1 will be 3 times 1 minus 1. And you know that 3 times 1 minus 1 is a 2. So that is a 2. So now you can see our new function is f of 2. Now we have to plug in 2 into the function f to evaluate this one. But f of x is x squared minus 4. So it will be 2 squared minus 4. 2 squared minus 4. And you know 2 squared is a 4. 4 minus 4 is a 0. So this composition, f o g of 1 is equal to 0. So I use one method here. I know that the inside function is g of 1. I evaluated that. then it becomes f of 2. So I plug in 2 into the function f, and I got 0. But for this one, there is also a second method that we can use. So let me show you the second method for this. Or we can do it like this. Let me write here. Or to find FOG of 1, we can do this. Look here. FOG of x, we got here. FOG of x is 9x squared minus 6x minus 3. So FOG of 1 will be, we plug in 1 into this equation. Okay, we plug in 1 into this expression here. So it will be 9 times 1 squared minus 6 times 1 and then minus 3. And you can see 9 times 1 squared is 9 minus 6 minus 3. That is, okay, 6 minus 3, negative 6 minus 3, that's a 9. So 9 minus 9, that is 0. So you can see either way, we get the same result. We got the same result, that is 0. So you can follow any procedure. If you already know the composite function, okay, if you already know the composite function, you can plug in and find the value. If you don't know the composite function, you can plug into the inside function, and then you plug in back to the outside function to get that composition. Okay, that is just the easy way of, handling problem like this one. So you can clearly see in this problem, we did a couple of things. The first one is we learned how to find the composition of function. Second thing, we learned to evaluate the composition of function using 2 different methods. Okay, that's all I have for this short video. I hope you enjoyed the video. Have a wonderful day, and I'll see you next time. Bye.